The use of AI in education is already widespread. The development of intelligent tutoring systems, IVS, has been a significant trend in the field of higher education since the 1990s and continues to grow today. ITs are used for online learning as well as face-to-face teaching. In fact, they have become so popular that they are now being integrated into academic institutions themselves. In this lecture, we will explore how artificial intelligence can be used to improve students' knowledge retention through personalized learning programs and automated grading. We will also look at some other ways that AI can be used to support teaching and learning in higher education, from student assessment tools to virtual classrooms. Finally, we will discuss what it takes for an institution or program to implement these technologies successfully. How does artificial intelligence work? AI uses algorithms based on machine learning techniques such as artificial neural networks, ANNs, and genetic algorithms, GA. These algorithms help computers learn by making predictions about future events based on past experiences with similar situations or data sets. This process is called supervised machine learning because data must first be labeled before it can be analyzed by the algorithm itself. For example, there must exist a training set which contains examples of correct answers along with incorrect ones prior to analysis. This approach works well when dealing with large amounts of data, but is not always effective when dealing with small data sets. ANNs are particularly useful because they allow machines to learn without being explicitly programmed. Instead, their behavior changes over time due to experience. Genetic algorithms take advantage of natural selection through evolution rather than explicit programming. GA allows computers to evolve solutions autonomously by searching through a space full of possible solutions until one emerges that performs best. Both methods require large amounts of data in order for them to work effectively. However, ANNs require millions upon millions of examples, while GA requires billions upon billions. While these two approaches seem very different on the surface, both utilize similar principles. If you give an algorithm enough information about your problem, it should eventually come up with a solution that works better than any human could ever do alone. It just may take longer than you would like, but then again, maybe not.